Today we'll be working on lesson 3.2, graphing quadratic functions, and today we're going to be working on the two forms of the quadratic functions, which are the vertex form and the root form. So together let's discuss what is the vertex form, or the general equation of the vertex form. Just like what we learned before in absolute value equations, the vertex form for the absolute value in unit 2 was y equals a absolute value of x minus h plus k. And the vertex in this case, we said that it's h and k. Remember that in unit 2? So it's called a vertex form because you're able to get the vertex right away from this equation. Now, how can we apply the same concept to quadratic equations, because this is absolute value? So what you do is, instead of the absolute value, you put parentheses and a square, and that's what's going to make it quadratic equation. So the vertex form is going to be y equals a x minus h to the second power plus k, where the vertex is going to be h and k. So this would be the vertex form. What about the root form? So let's discuss what is a root form. The general equation of a root form is y equals a x minus r1 x minus r2, where the roots in this case are going to be r1 and r2. These are going to be your roots. And this is why it's called a root form, because you're able to get the roots right from the equation. We're going to have more practice on that, so don't worry if you don't get it 100%. So let's move on to our first problem, and let's discuss this one over here. F of x is equal to 2 x minus 5 to the second power minus 8. Now, what do you think this is called? Is this going to be the vertex form or the root form? As you can see, we have parentheses and to the second power, so that's going to be my vertex form. And again, it's called vertex form because you are able to get the vertex right from the beginning, okay? So let's try to find what the vertex is. As you can see, vertex is going to be the h, so it's going to be the opposite number, the opposite of the number on the inside. So in this case, it's going to be 5, and the k is going to be the number on the outside, and in this case, it's negative 8. So the vertex is going to be 5, negative 8. That's how you find your vertex. Now, do you think this is going to be a minimum or a maximum? To decide whether it's a minimum or a maximum, just like in Unit 2, we look at a, which in this case is 2. So is a positive or negative? It's positive. So that's why it's going to be a quadratic equation that's going to be opening up. It's a parabola that opens up. In this case, we have a minimum. Okay? So you can find all of that by looking at the equation. But if you feel that's something that you would like to see on the calculator, you can also do that. So let's try to graph our equation. So it would be nice, guys, to be able to know how it opens right from the equation, and that you can tell from A. And it's also good to be able to tell the vertex from the equation. But you can always graph it and look at your graph. So as you can see, we have a vertex that's a minimum, and we already know that. Now let's see how we can find the vertex on the calculator. You can go to second graph, which is the table, and the vertex is always going to be that point where the y values will be reflecting. So as you can see, we have 5, negative 8, 0.5, negative 8, and the y value is negative 6, negative 6. You see that up and down. They keep on reflecting. So that is going to be my vertex, and this is what I can find right from the equation, but you can always look at your table and check your answer. So 5, negative 8 is going to be my vertex. So let me plot that. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So my point is going to be outside of my graph, so that's going to be my vertex. Now, let's look at the other questions that we have in this problem. So they want the y-intercept. What is the y-intercept? The y-intercept is the point on the y-axis, so where the graph crosses the y-axis, and it will always have an x of a 0. So if you look at your calculator, you'll see that 0, 42 is going to be your y-intercept. So again, the y-intercept is where the graph crosses your y-axis. What about the x-intercept then? The x-intercept is where the graph crosses the x-axis, and in this case, the y is always going to be 0. So by looking at my table, I can see that 3, 0, that's going to be my first x-intercept, and my second intercept is going to be 7, 0. You see that? 7, 0. So x-intercepts in this case are 3, 0, and 7, 0, and basically they are the points on the x-axis, and the graph is going to pass through those. So let's plot them. Okay, now you can get more points to make your graph look better. So that's going to be my parabola going through these x-intercepts, going through the minimum, and then going through the other x-intercept. So that's going to be my parabola. Now, what do they mean by roots and zeros? Roots and zeros are basically just other names for x-intercept. They mean the same thing. So the roots or the zeros are the points on the x-axis where the graph crosses these points. So these are the two roots. So in this case, my roots are x equals 3 and x equals 7. Now, what about the domain and range? Now, if you look at your graph, let's look at our graph. As you can see, it stretches on forever from negative infinity. It goes on to the left to negative infinity forever, and goes to from the right side to plus infinity always forever as well. So my domain for quadratic equations is always negative infinity to positive infinity, because as you can see, it stretches on forever from the left and the right side. Now, what about the range? The range is from the bottom all the way to the top. The bottom, it stops at this vertex, at this point. There's no part of the graph that goes below this point, so you have to start from the y of the vertex. In this case, it's negative 8. So your range is going to go from negative 8 inclusive, since the graph is going through this point. And as you can see, your graph stretches all the way up, so it's going to go to plus infinity. So this is how you do the vertex and the a by looking at the equation, but you can always check by graphing it on your calculator. So remember, if a is positive, it opens upward, and you will always have a vertex that is a minimum. What if a is negative? Then it would be a graph that opens downward, and it will have a vertex that is a maximum. So let's move on to our second example. I think I need to rotate this page to get to my second example. So let's look at this over here. In this case, what do you think? Did they give me the equation in vertex or in root form? Let's check. As you can see, you have parentheses, so that's going to be my root form. I do not have parentheses with a second power, so that's going to be my root form. And it's called a root form because you're able to get the roots right from your equation. So what is my roots then? My roots are going to be 3 and negative 1. You always take the opposite of what you have in the parentheses. So I know my roots are 3 and negative 1. Then I know my x-intercepts are going to be 3, 0 and negative 1, 0. Because when you say x-intercept, you mean you need the point. And that's the point where the graph crosses your x-axis. So always the y of the x-intercept is going to be 0. Now you can always graph this on your calculator and check. But it's always good to know what you're able to find from your calculator to just save time on the test, let's say. And realize that a root form will give you always the root. So let's graph this and see what we get. So as you can see, it's going through negative 1 and going through 3. So these are going to be my roots, but I can always go to my table and double check. Now remember, the vertex is going to be the point. So let's look at the roots since we're talking about the roots now. So the roots are going to be the ones having a y of a 0. So as you can see, 3, 0 is going to be my first root, and negative 1, 0 is going to be my second root. But I already know that from the equation, but you can always check. Now let's try to find the vertex. The vertex is going to be the point where the y values will be reflecting above and below. So as you can see, my vertex is going to be 1, negative 8. Because look, negative 6 on top, negative 6 on bottom, 0 on top, 0 on bottom. All the y values are reflecting. So in this case, my vertex is 1, negative 8. So let me plot 1, negative 8. And my two roots. So I know my graph is going to go through these roots, through that vertex, and going up. Now we didn't discuss, as you can see, it's opening upward, and you could have told me that by looking at the A. The A in this case is a 2, it's a positive 2. So it's going to be a parabola that opens upward, having a vertex that is a minimum. It means your vertex is going to be the minimum point of your graph, and no part of the graph will go below it. That's why it's called a minimum. And as you can see, the minimum is 1, negative 8. So let's go to second table again and try to find our y-intercept. The y-intercept is the point where your graph is going to cross the y-axis. In this case, as you can see, 0, negative 6 is my y-intercept. So remember, the x of the y-intercept is always 0. Now let me see if I did a good job over here. 1, 2, 3, 4, 5, 6. Yes, it did go through negative 6, 0, or 0, negative 6. Now, this is how you solve a root form. As you can see, it's very similar to a vertex form if you have a calculator. You do the same steps. Now, what about the domain? Like we discussed earlier, the domain is going to be from the left to the right, so from negative infinity to positive infinity. So, negative infinity to positive infinity. And the range is going to be from the bottom all the way to the top. Okay, so in this case, it's going to be through the y of the vertex all the way to infinity. Okay, now what I want you to do is I want you to pause the video and try to do the second one on your own to better understand it. Okay, I do hope that you tried on your own. Now let's see what we can get from this equation by just looking at it. I can tell what my A is. I can tell that my A is negative 1. In this case, since A is negative, it's going to be an upside down parabola having a vertex that is a maximum. So then I have a maximum vertex. Now what is my H? My H is going to be the number that's inside the parentheses. You always take the opposite. And the k is going to be the number on the outside. Since I don't have a number on the outside, then the k is going to be 0. So my vertex is negative 5, 0. So that's the negative 5, 0. Remember, you can always graph it to double check. X plus 5. Now you always need to graph it to be able to get the roots. So as you can see, the vertex is negative 5, 0, so my graph is going to like touch and bounce back, bounce off the x-axis, so my vertex is negative 5, 0. As you can see, since it's crossing the x-axis at that point, then my x-intercept is also going to be negative 5, 0. As you can see, my graph touched the x-axis only in one point, so I only have one x-intercept and one root. Okay? So as you can see, the vertex is also the x-intercept because the graph touches and bounces off the x-axis, doesn't go through it. And we don't have two roots. It's not crossing the x-axis in two parts. So let's go to the table to verify that. Now if you look at negative 5, 0, you'll see that all the y values will be reflecting. So yes, negative 5, 0 is my x-intercept. And since y is 0, that's going to be also my x-intercept. Did I say y-intercept? So the vertex is negative 5, 0 because everything else, all the y values are reflecting. So negative 5, 0 is going to be my vertex. And since the y is 0, is also going to be my what? My x-intercept. What about my y-intercept? Let's try to find the y-intercept. It's the point where x is 0. So there you go, 0, -25. That's going to be my y-intercept. Now let's graph this. Let's get a couple of points. So I'm going to take -6, -1. And I'm going to take -4, -1. And that's going to be my parabola. As you can see, it's an upside down like we said before. It's an upside down parabola. It's a reflected parabola because we have a that's negative. And it's enough to have two points other than the vertex for you to be able to graph it. As you can see, the domain is always -infinity to infinity no matter what, because it goes all the way to the left and all the way to the right. So yes, the domain is always -infinity to infinity for quadratic equations. What about the range from bottom to top? As you can see, there is no bottom. It continues on forever. So then from bottom, it's going to be a -infinity all the way to the top. So it reaches a maximum, and there's no part of the graph that goes above that. So then my range goes all the way to the 0 of the vertex, in this case, to the y of the vertex, which is in this case is 0. So the range is from -infinity to 0. Remember, you always look at the y of the vertex to get your range. Now, I hope this was helpful, but I would like to do a problem with you where the vertex is not a pretty point. And remember, if the vertex is not a pretty point, it's not something that you can find off the table. So you should have a plan B. So I'm going to take one example and do that one with you. So this is going to be from your practice sheet, number 3. Y equals 2, x plus 1 squared minus 4. Now let's try to find, now as you can see, the vertex is a pretty point. It's -1, -4. But let's see what is going to, remember, the vertex is always going to be the h and the k. So in this case, the h is -1 and the k is -4. But you can always verify that on the calculator. So I'm going to go to y equals, I'm going to graph that, and together we're going to see if any of my x-intercepts or my vertex, if it's not a pretty point, what is it that I can do to find it? So it's 2x plus 1 squared minus 4. So let's go, first let's graph it. So step number 1 is always to graph. Now as you can see, it's the parabola that opens upward. Let's go to our table. Let's see if we can find the vertex. So let's find it. Okay, as you can see, -1, -4 is my vertex because like the y values reflect. So that is a pretty point. I was able to find it off the table. Now, what if the vertex is not a pretty point? How are you able to find that on the calculator? So I'm going to assume that my vertex is not a pretty point. So vertex on the calculator, what are the steps if it's not a pretty point? So number 1 is to graph it. Number 2 is to go to second trace. Let me push this down a little bit so you are able to see that. Now, if you go to second trace, you'll see that you need to pick an option. So look at your graph. Is this graph having a minimum or a maximum? A minimum. That's why you always need to graph it first. Let me push this to the side. Okay, so you always need to graph it and then to go to second trace and decide which button to press. Do you need to press number 3 for minimum or number 4 for maximum? In this case, I need to press number 3 because it's a minimum. So I'm going to press number 3. Now, once you press number 3, it's going to tell you or ask you for a left bound and a right bound. So step number 3, choose a left bound and a right bound. And what do I mean by left bound and a right bound? It means if I have my parabola, and this is, for example, my vertex, I need to pick a point to the left of the vertex, and that's going to be my left bound, or a point to the right of my vertex, and that's going to be my right bound, okay? So that's going to be my right bound. So they're asking for the left bound. So let's move the cursor to the left of your vertex. There you go, and press enter. Then move, as you can see, it's asking for the right bound now. So move the cursor to the right of your vertex and press enter. Once you do that, you'll see that you have two arrows showing that the vertex is going to be between them. And yes, the vertex is between those two. So I'm going to guess by pressing enter. And it's going to tell me that my minimum, as you can see, since I chose minimum, is -1, -4. And this is what I found earlier on the table. So this is what you need to do if your vertex is not a pretty point. You need to go to second trace and try to find the left and the right bound to be able to get your vertex. Now, let's try to find our x-intercepts. So I'm going to go to second table and try to get the x-intercepts from there. Now, by looking at my table, I'm looking for the x-intercept. So I want to look at the points having a y of a 0. Can you find it? I can't find it. So probably my x-intercepts are not pretty points. So what do I do in this case? The same thing. So let me push this up and let's try to take notes. Now, so what to do or how to find the x-intercepts if they are not pretty point on the calculator. The same thing. Number one, you need to graph it to see how it looks. So we already did that. Now, second step, what do you think? We need to go to second trace. So I'm going to press second trace. Now, we have different options. Remember, if you want the vertex, you press 3 and 4, but if you want the x-intercept, you need to choose something else. What is another name for x-intercept? Roots, zeros. So root or 0 is a different name for the x-intercept, so you need number 2 if you want to find the x-intercept. So click on number 2. Now step number 3 is like before, you need to choose the left bound and a right bound. Now if I have this graph, and this is going to be my, let's say, coordinate plane, as you can see, how many x-intercepts do I have? 1, 2. So if I want to find this x-intercept, I have to do these steps. And then if I want to find this x-intercept, I have to do these steps again, okay? So how can we do that? I'm going to push this down. So once you press number 2, it's going to ask you for a left bound and a right bound, just like the vertex. Now, if I want this x-intercept, I need to choose a left bound to this x-intercept. So think of a vertical line over here. Where would be the left of this vertical line? Here. So then my left bound should be somewhere in this area. So I'm going to move my cursor to the left of my x-intercept. There you go. Think of a vertical line passing through your x-intercept, and the left bound is going to be a point to the left of this vertical line. So once you chose your left bound, press enter. Now it's asking you for the right bound. So think of a vertical line again going through your x-intercept, and your right bound is going to be a point to the right of this vertical line. So I'm going to move my cursor to the right, somewhere as close as I can be to my x-intercept. So press enter. As you can see, that's true. Look at those two arrows. My x-intercept is between those two arrows, so I'm doing good so far. So I need now to do an educated guess and press enter, not me, the calculator. So as you can see, the x-intercept is -2.410. So you write your x-intercept. The first one is going to be -2.41, 0. That's your first x-intercept. Now you need to find your second x-intercept. So let's go back to our graph. Let's go back to our graph. And this is my second x-intercept, right? So I need to do the steps again, and which are graph, which I did, second trace. And then I need number 2, because I want the 0, the x-intercept. And then I need to do a left bound and a right bound. Now remember, I want this x-intercept. So think of a vertical line going through this x-intercept. You want a left bound, so you want a point on the left of your x-intercept. So I'm going to move my cursor to the left of this x-intercept, as close as I can be, not on it. Okay, that's close enough. So this is my x-intercept. Think of a vertical line. This point is to the left of my x-intercept, which is good. And I press enter. And now I need a right bound. So I'm going to move my cursor to the right of this point and press enter. So my x-intercept is between these 2 points. So I'm going to press enter for guess, and it's going to give me my second 0, which is 0.410. So that's my second x-intercept. So as you can see, we had to do the steps twice because we have 2 x-intercepts. So what did we say our next point? It's 0.41, 0. So that's going to be my second x-intercept. So this is how you find your x-intercept if it's not a pretty point, by going to the second trace button. Now I hope this video was helpful. Please go to the website for more practice and more answer keys.